Okay, welcome everybody. I'm going to go over some quick terminology here that we need as we move into the polynomial section. Just a few things that they should all be reviewed, but again, if they're not, then at least we'll have covered them together. So first thing, just the term function, the course is advanced functions, and so of course I'm interested in knowing what a function actually is. And basically a function is any relation where every x value only has one y value. So again, pretty straightforward stuff. If I tell you that we're looking for x being the value 2, you can always say that y is a specific value, and no two people can have a different answer and both be right. In order to test that, if you actually see a graph, we use what we call the vertical line test. And so pretty simple stuff. Again, you've got your grid. You have some sort of a curve, and provided you can run a vertical line that does not touch the graph at 2 points at the same time, then the original graph was a function. Okay, so this is the vertical line test kind of going across here. You can see that I'm only touching the blue at 1 point all along the way. An example, of course, something that would not be a vertical line, or sorry, that would not be a function. A circle is a great example. As I run my vertical line test, you can see I'm hitting the circle at multiple points. Well, at 2 points specifically at the same time. So that's just function. The first section, of course, is polynomials that we're looking at. So polynomial expression has this form. And I know that the math writing sometimes is pretty ugly. And so, quick example here again. Something like 3x to the 12th minus 4x to the 6th plus 2/3 x plus 9. That's a polynomial expression. So the rules are n must be a whole number, so your exponents have to be whole numbers. 12, 6, there's a 1 here, and this is x to the 0, so we're good. X is variable, I just used x again, no problem. And the coefficients are real numbers, so 3, -4, 2/3, all real numbers. Okay, so you remember your whole numbers are 0, 1, 2, and so on. Your real numbers are fractions, negatives, decimals, basically any number that actually exists. Moving forward, degree, in this case 12 is the degree of this expression. It says that the degree is the exponent of the greatest power of x. So again, we tend to organize things in decreasing exponents, biggest exponent first, and then as we go down. And so the biggest exponent will be our degree. And then an, the coefficient of the greatest power of x, is the leading coefficient. Okay, so just sort of again terminology. These are coefficients. The leading coefficient is the first one. Not really very important, but just terms, expressions that you'll see in the work. A0 is a term of the variable, the constant term, this one over here, because it can't change regardless of the values of x. And polynomial function now is just kind of combining those two things. So essentially we've got an equation instead of just the expression. Much like in grade 9, 3x minus 4 was an expression. Y equals 3x minus 4 was an equation. And then power function is just anything that's in that form. Power functions have similar, okay, this stuff, I left it in, but we'll see this sort of as we go through today's stuff. The symmetry is maybe more important. Even powered functions have a line of symmetry. Now, I don't care about even function, odd function, sorry, even degree, odd degree. But what I do care about is the fact that we recognize what symmetry means. And so in the first case, they're suggesting even degree functions have a line of symmetry. So even degree is something with like a degree of 2. And of course, if I could actually draw something properly here, this would be your quadratic function from grade 10 and 11. And if it's drawn perfectly, of course, you have perfect symmetry in that this side is exactly the opposite of this side. As I move out here and I go up, as I move out here I go up by the same amount, and there's a corresponding point across from it all the time. So that's a line of symmetry across the, in this case, the y-axis. And the point of symmetry that you talk about for the odd degrees, if we think about a cubic function, it's a little bit better. What we see up here is identical to what we see down here if we rotate it. So if I could just take this part and rotate it around, and again, this was drawn properly, it would line up perfectly with this one. Okay, so symmetry again just means that one side is identical to the other, depending on whether it's across a line or rotating around the point in this case. Guess I could have left those on. So today, essentially, you're going to be going through the investigation in the textbook. The textbook we're using is the McGraw-Hill-Ryerson textbook. I'm going to have an online version available to you in the next little while. It takes a while to order them. But for chapter 1, I'm just going to post the entire chapter, and if you want to print out individual pages, you can. I would think that you don't want to print too many of those, but you at least you'll have them available on the website. So essentially what this is asking us to do is just graph all the values from the group. My suggestion is we're going to use Desmos for most of the things we do this year. It's just, I think, the best free online graphing calculator that's available. So when you go to Desmos, and you can just type desmos.com, it'll jump you to this page, and then you hit launch the calculator, and you'll see that the actual website is desmos/calculator. And then basically you're going to take the expressions that are written here, x cubed plus x squared, and so on, and you're going to put them in there. I've lost my other page. Sorry. And to input, basically you can see down here we have x, and obviously it starts a graph as soon as we get in. The exponent is going to be, oh no, I missed it, sorry. The exponent is actually right here, and we want x cubed, so you just hit that button, it gives you an exponent, you switch it up. So there's my graph for x cubed right away. If I want to do another, I can just click below and start the next one. The second one was x cubed plus 4x squared, and the x squared is kind of an automatic one, and you can see that the second graph is being drawn while I type. I don't know how well you can see that actually. If I go to, oh, they've changed it a bit. Settings up here, I can switch to projector mode, and it's a little bit brighter, but we'll use this extensively and get better with it as we go. Essentially for today, this is what I want you to do, and as we go through the investigation, it basically asks you to draw those three different graphs, and then kind of look at them and determine a few things. I think most of the terms in here will be pretty obvious. Hopefully you recognize what x-intercepts are. X-intercepts are the points on the x-axis. Local maximums and minimums, even if you don't recognize those terms, they're pretty obvious. A local minimum would be sort of this point where there's a local low point, and local maximum of course would be up here. And the one probably that might sound a little different to you is end behaviors. Essentially we're asking what happens as we move out on our graph. as the x values go this way and the x values go this way? Well, in this case, as I move further out, as my x values increase, my y values increase as well. As we go to the left here, as my x values go greater and greater negatively, so does my y value. And so how we tend to write those things, for now, we'll just say that as x heads out towards infinity, y also heads towards infinity. As x heads towards negative infinity, y heads towards negative infinity. And of course, depending on the actual equation you're looking at, this will change. As I'm going out this way, I also could go up towards positive infinity, I guess we'll say. And as I go out this way, of course, I could go down towards negative infinity as well. So finally, compare the two groups, describe the similarities and differences. So again, you're just looking for whatever you can kind of come up with based on the fact that you have 3 or 4 examples there. How do these two things compare? Do they look similar? Do they look different? And just kind of get an idea of what a graph that starts with x cubed specifically looks like versus a negative x cubed. And then which group of graphs is similar to these, explain how they're similar. So don't worry about writing a story here. I'm not collecting this for sure, but you want to have an idea moving forward what x cubed looks like. And anything that's related to x cubed, you have an idea at least, oh, it goes kind of like this. Anything that looks like x squared, you have an idea already, is a parabola. So we're trying to get an idea about some of the other options. And so once you have a pretty good idea what the various graphs look like, we'll be able to apply those to different problems. So that'll sort of be the next step along the way.